Hello, Algebra 2 students. Hope you are doing well. This is a lecture on section 5.1, which is using the properties of exponents. Now, in your Algebra 1 course, you learned a bunch of properties of exponents. This was spread out over multiple sections, and you were introduced them one at a time. In Algebra 2, we're saying, hey, you already learned all these properties of exponents. You should know how to apply them, and this is going to be a review of all of the properties that you learned in Algebra 1. The goal of the properties of exponents is we want to be able to simplify statements like x to the third times x to the fifth. If you were just looking at this, you might guess that this is equivalent to x to the 15th, but that is not true. If we think about what x to the third means, that means x times x times x, right? X to the third means x times x times x. Then we're going to multiply that by x to the fifth. That would be x times x times x times x times x. What is this equal to? Well, this is 8 x's right here. Here's 3, here's 5. They're all being multiplied. This is equivalent to x to the 8th power. And so we don't want to actually have to go through the work of writing this out to figure that out. So we're going to develop these properties of exponents. And there's quite a few of them, and you're going to need to know how to apply them. Here's the list of the properties of exponents. I am never going to quiz you on the names of the properties. In fact, I don't particularly care. I just want you to know how to apply them. The previous property that we saw, x to the third times x to the fifth, that is this one here. What this says that you can do is if they have the same base, like a, and they're being multiplied, you would add their exponents. 3 plus 5, that's how we got x to the 8th. The power of a power property says that if you have something being taken to a power, and that is being taken to another power, then you would multiply them. An example here would be you have 3 to the third power, and that's being taken to the second power. You simply multiply these and get 3 to the sixth. And then if you wanted to simplify it completely, you would 3 to the sixth is 729. Our third property says if you're multiplying two things together, and then they're in parentheses being taken to a power, you can apply that exponent to both of the terms, the product, the numbers that are being multiplied. So this would apply like this: 3x in parentheses to the fourth is the same as 3 to the fourth x to the fourth. This is going to show up a lot where you have negative exponents. Except for scientific notation, you should never have a negative exponent in your final answer. If you ever have a negative exponent, move the base, like a here, move base to the opposite place. And what I mean by place is if it's in the numerator, move it to the denominator. And if it's in the denominator, move it to the numerator, and then make the exponent positive. So in this case, if you had a to the negative mth, you would move a to the denominator and then make the exponent positive. You'll see that here, 7 to the negative second. 7 is being taken to a negative power. Move that to the denominator and then make the exponent positive. 1 over 7 to the second, which is 1/49. One of your properties says if you ever have anything being taken to the 0th power, that is equal to 1. This is always going to be true. Any number to the 0th is 1. The quotient of powers is similar to the product of powers. Here, remember, when you multiplied with the same base, you'd add their exponents. When you divide with the same base, like a and a here, you subtract their exponents. And then the power of a quotient property, if you have a fraction being taken to a power, you can apply that exponent to the numerator and to the denominator. Here you see it play out. 4 divided by 7, or 4/7 to the second power, you can apply that exponent to the numerator and to the denominator. These properties are not going to be used, for the most part, like one at a time, like you see here. They're going to be used in conjunction with one another. There's going to be problems that you're using a bunch of them, and you guys are going to be responsible for using them properly. Let's take a look at some examples here. -4 times 2 to the fifth. Because these do not have the same base, you can't combine those, right? One base is -4. This would be like -4 is kind of being taken to the first power, times 2 to the fifth. They are not the same base, so we can't combine them. We do have a property that says if we're multiplying two things, we can take this exponent and apply it in. Anytime you have a negative being taken to a power, that negative number has to be put in parentheses. So this would be the same as -4 to the second, but the -4 has to be in parentheses, times 2, and one of our powers says that if you have something being taken to a power, being taken to another power, you multiply them. And this would be a satisfactory answer for that problem. There's lots of ways to answer this second question up here, 11 to the 5th divided by 11 to the 8th. One of the ways is that you could take this exponent and apply it in both to the numerator and to the denominator. This would be using multiplication just like it was here. So you'd have 11 to the negative 5th over 11 to the negative 8th. You have another property that says if you are dividing with the same base like you are here, you subtract their exponents. And subtracting the exponents here, negative 5 minus negative 8 is actually positive 3. Because it's positive, it's going to be in the numerator, and that would be my answer. Another way that you could have answered the same question is said, hey, they have negative exponent. This has a negative exponent. That means it has to be moved to the denominator and make the exponent positive. This one here has a negative exponent. That means it has to be moved to the opposite place. That would be the numerator and then make the exponent positive. From here, you would subtract them, and you would get 11 to the 3rd, same answer. A couple more examples here. You have negative 8 in parentheses times negative 8 in parentheses to the second. If something doesn't have an exponent on it, we know that that is being taken to the first power. Negative 8 to the first times negative 8 to the second. These have the same base of negative 8. When they're being multiplied, you add their exponents, negative 8 to the 3rd power. This is going to be, all these problems are review and are honestly just going to take some practice to make sure that you're getting the right answer. I'm going to do a couple more of them. Here, the coefficients like 16 and 2, when they don't have exponents, you're still going to use your normal math skills to answer these questions. 16 over 2 we know is 8. M doesn't have anything like it, so M is just going to stay put in the numerator. And then for our n's here, they have the same base and they're being divided. That means we subtract their exponents. 5 minus negative 8 is 13. And because it's positive, it's going to be in the numerator. 8mn to the 13th. They do get more complicated, more starts happening, all that fun stuff. This one here, we can apply that exponent to everything in the parentheses. We do that using multiplication, so x to the negative 6th, y to the 6th, over x to the 5th, y to the 6th. From here, the x's have the same base and they're being divided, so I could subtract them. I would get x to the negative 11th and y to the 0th. X, not 11. Now, x has a negative exponent. That means that we know it's going to have to get moved and make the exponent positive. This is in the numerator now. It's going to get moved to the denominator, make the exponent positive. That takes care of the x. We also have a property that says anytime you're taking something to the 0th power, that is just 1. So 1 over x to the 11th would be our answer here. Great time to pause this one and try it out, see what you guys get, make sure that you are doing this correctly. 2 over 6 would simplify to 1 over 3. The x's are being divided with the same base. That means you subtract their exponents. If it doesn't have an exponent, that exponent is 1, and 2 minus 1 would be x. Now we can work with the y's. Once again, this y didn't have an exponent, so I just wrote a 1 there. 1 minus negative 1 would be 2, so y squared. 1xy squared over 3, or we could just write this as xy squared over 3, since that 1 doesn't really do anything. So that's all we got for section 5.1, the properties of exponents. I'm going to encourage you guys to be working with these problems, attempting some of these problems, making sure that you're getting your answers correct. And let me know if you guys have any questions. Thank you.